The easiest lie your eyes tell. Close one eye. Now point at something across the room, maybe a doorknob, a lamp, the corner of your screen. With one eye closed, it feels obvious. You see it. Now open both eyes. Same object, same room, but your brain has quietly stitched together depth, distance, and meaning without asking your permission. Here's the twist. For most of human history, even brilliant thinkers didn't truly agree on the most basic question behind that simple moment. Do our eyes send something out into the world, or does the world send something into our eyes? That question isn't just about vision, it's about how knowledge is earned, and about a man who lived roughly 6 centuries before Galileo, a scholar from the Islamic Golden Age, who insisted that a claim isn't true because it sounds elegant, or because an authority said it, or because a tradition repeats it. A claim becomes trustworthy only when it can survive something harsher, a test. The world before tested it. In the ancient Mediterranean world, there were powerful theories of vision. Some argued that sight worked because the eye emitted rays outward, almost like a lantern. Others argued the opposite, that something entered the eye. The debate lasted for centuries, and it's worth pausing here, because this is where modern viewers can misunderstand the past. People weren't stupid. They were operating inside a different culture of proof. If an idea matched philosophical expectations, if it lined up with geometry, if it fit the authority of famous names, it could dominate for a very long time, even if it was wrong. Then, in the 10th and 11th centuries, in a world stretching from Iraq to Egypt, a new style of thinking was sharpening, one that treated nature like something you could interrogate, not with opinion, not with reputation, but with repeatable procedure. Enter Ibn al-Haytham. A life turns into a laboratory. His name, Abu Ali al-Hasan ibn al-Hasan ibn al-Haytham, known in Latin as Alhazen. He was born in Basra around 965 and later died in Cairo around 1040. He wrote across mathematics, astronomy, and physics, but history remembers him most for optics, because optics became his battlefield against good-sounding ideas. There's a famous and partly debated story about how he ended up in Cairo. It says that Ibn al-Haytham proposed a plan related to controlling the Nile's flooding, and that the Caliph al-Hakim summoned him to Egypt. When the plan proved impossible, the story goes, Ibn al-Haytham feared the consequences and, depending on the version, feigned madness or otherwise fell out of favor, leading to confinement. Historians discuss details differently, but multiple accounts agree on the outcome that matters for our story. Ibn al-Haytham spent a period under restriction in Cairo, and in that constrained space, he produced work that would echo for centuries. Because sometimes history's strangest engine is this: a door closes, the world narrows, and one mind turns the room into a universe. The Book of Optics, where seeing becomes science. Between roughly 1011 and 1021, Ibn al-Haytham wrote his 7-volume masterpiece, Kitāb al-Manāẓir, known in English as the Book of Optics. This wasn't a book of vibes. It was a systematic attempt to explain vision, light, reflection, refraction, grounded in geometry, and, critically, experiment. One of the most famous tools in this story is the camera obscura, a dark room or box where light enters through a small hole and forms an inverted image on a surface inside. The Book of Optics discusses and uses this type of demonstration to reason about how light travels. But the bigger revolution wasn't the device. It was what the device represented, a claim about nature that you could check with your own eyes, on demand, using a procedure you could repeat. And Ibn al-Haytham used that mindset to challenge one of the oldest popular ideas in optics, the belief that the eye sends rays outward. Instead, he argued, carefully, with reasoning and tests, that we see because light reflects from objects and enters the eye. To modern viewers, that sounds obvious, but to a world trained to respect ancient authority, It was a direct challenge. The method, what made him father of the scientific method. You'll often hear Ibn al-Haytham described as an early architect of the scientific method, sometimes even the first true scientist. Ibn al-Haytham is famous because he explicitly tied knowledge to a cycle. Even modern science writers point to this experimental emphasis as a key feature of his approach, especially in how he treated optics as something you could prove with tests and geometry rather than inherited doctrine. So when people call him the father of the scientific method, the strongest, most defensible meaning is, he helped make experimental verification and mathematical proof central to scientific claims, centuries before that style became standard in Europe. The argument with authority, doubts concerning Ptolemy. Ibn al-Haytham wasn't only challenging old theories about eyes and light, he also challenged a deeper habit, the habit of building systems that save appearances, systems that can be adjusted endlessly to match observations without ever admitting the framework might be wrong. His critique of Ptolemaic approaches appears in works often referenced as Doubts Concerning Ptolemy, where the target is not one wrong number, but the standards of proof behind the numbers, whether a model is demonstrative or merely convenient. This matters because it reveals something about his personality as a thinker. He wasn't trying to win an argument. He was trying to build a world where arguments are settled the same way, every time, by evidence that other people can check. That idea, more than any single discovery, is what makes him feel so modern. How the ideas traveled, from Arabic science to European optics. A great discovery only changes history if it moves. The Book of Optics did. Sources describe it being translated into Latin around the late 12th or early 13th century, helping place Ibn al-Haytham's optics into the intellectual bloodstream of medieval Europe. Centuries later, a printed Latin edition, often associated with Friedrich Reisner's 1572 compilation, helped spread the work further at a moment when European natural philosophy was transforming. And if you zoom out, you see the pattern. A scholar in the Islamic Golden Age produces a rigorous experimental mathematical approach to optics. The work circulates, gets translated, and becomes part of European perspectiva traditions in the Middle Ages. Later, early modern scientists push further, often wrestling with the same geometry of light, lenses, and vision. You don't have to claim one person caused everything to see the influence. But it's hard to tell the story of optics without him, the real inheritance. So what did Ibn al-Haytham truly leave behind? Yes, key insights into reflection and refraction, and a powerful case for how vision works. But the deeper inheritance is philosophical and practical at the same time. He treated nature like something that must answer to procedure. Not charisma, not tradition, not the loudest voice in the room. And that is why, a millennium later, his story still feels like a message to the future. If you want the truth, don't just argue for it. Build a test that can prove you wrong.